Hi, so in this class of IoT, today we will study about the various protocols which are used in your Internet of Things here. So here we have today the IoT protocol stack. Now if you just have a look here on the stack, so we basically start from this standard, just in one case, and then we have here so in IoT, we start here from this very basic layer. So these are the devices itself running over protocols like your Zigbee or your RFID here. Then after, we know that these devices are connected to some local networks, that is they're using some gateways in order to get the information from these devices and simultaneously to transfer information to these devices. After that we have the internet integration at this level. We have the internet integration. That means local gateway technologies here are also dependent on your protocols like IPv4 and IPv6. Now, mainly we are using here IPv6, so we have like this protocol here. Now, after the internet integration, we need to connect to the end devices. That is your end devices, the user application part here. So that means this is the collection of data. Integration, that means the processing of the data and then transferring it to the end devices, or it could be your cloud infrastructure. So the various protocols which will be used here are like your MQTT, your coAP, your XML, or your different web sockets here. Now traditionally for internet we're using the protocols like your HTTP, Hypertext Transfer Protocol, and for your network and transport layer we have TCP IP. But these are not here the optimum protocols for your Internet of Things here. Because your Internet of Things here has a constrained environment. So that constrained environment basically come from the constrained nodes which are used here. If I'm talking here about this constrained environment or constrained network here, so that means it has some elements like that, the nodes. So the requirement of these devices are different. These are low powered, operating on low frequency and uh, low throughput devices. So this is the one constraining factor here. So to enable the communication for these devices, that means they are able here to transfer the information to the internet, we require certain protocols. Means such kind of constraint protocol so that they are able to transfer the different header and the data across these different nodes here. So we are not using, although the protocols which we will be using here in IoT, they're aligned with HTTP, but we're using different constraint protocols that are here able to support these low powered devices. So the protocols which are used here are like your coAP, MQTT, XML-based protocols. So first of all, we will study this protocol, which were basically introduced by IETF so that it could support or it could meet the requirement of your IoT devices here. So this is your constrained application protocol. So this protocol is designed here so that it can support the low power devices and the lossy networks. So this is the standardized protocol here for IoT, the first one which we are studying here, that is able to allow the communication here between the various IoT devices and connecting them to the internet. So we have constrained application protocol which will run in the constrained environment of your IoT system here. Now, previously we know that we have been using for your IPv4 and IPv6 the TCP. It is a transmission control protocol. But this existing web infrastructure can support the IoT devices also, but the protocols which are used here are quite heavy for these devices. So as we know that this IPv6 over low power personal area network is also a lighter version of your IPv6, enabling the IPv technology here. So similarly, we just don't have to use here the transmission control protocol also because it has a larger overhead. So instead of that, here these protocols are based on or they're using UDP, which is your user datagram protocol. So most of the functionalities of this TCP are directly replicated into this protocol because this protocol also provides low latency and low throughput for your IoT devices here. So we are today going to study about the constrained application protocol, that how it will allow the exchange of information on this header between the internet and the constrained environment. So in your web infrastructure, you have the client, which is your user, which is connected to these various servers, this web of internet, using this proxy here. So your coAP protocol is here simultaneously aligned with HTTP. That means we can connect to this in case if we want using the proxy server. So now how this is enabled is, so we will have your internet, mostly IPv6 here for your IoT, then your constrained environment. So these protocols are here designed in keeping things in mind that it should support the platform of your IoT. So we will have for these protocols, if you just have a look at the stack of these protocols, you will start here from these constrained links. which will be the devices itself, the low power devices. After that, the IP, then your UDP and the web resources. So this is your UDP transport, which enables the transportation of these information between these two nodes, your internet and this environment. And web resources will have different kind of messages, like your MIME type messages here. And next is the transaction model for this constrained application protocol here. So if we just have a look at the bigger picture of the internet here, you will have different servers in this web of internet. Here you will have your second constraint environment. So the devices here will be enabled with this constraint protocol so that they can exchange the information with the internet here. Now here suppose you have your this system. So all of the clients, means the various devices here, will be using this protocol. Now this is the proxy server here. So we can say that this it is easy to proxy this HTTP with this constrained environment in case if we require that. Now these are the different nodes of your constrained network here. So this is simultaneously aligned here, so it will have the HTTP mapping here. So the various messages which will be here exchanged across this network will be like your caching and resource discovery, reliability. There will be some sleeping nodes also. So this is the core environment, and these are the core requirements that yes, you are connected here to the internet. Now we have to exchange the information from the internet. So this is how your coAP protocol will work. This is a scenario for a proxy server, that is HTTP mapping will take place here, but rather for these devices here, these constrained uh, nodes here, we will have this coAP protocol running between this server and these various devices. So the first feature here is that this protocol uses the UDP, your user datagram protocol, and the functionalities of TCP are replicated itself to the coAP. Now, two type of messages are here exchanged between the server and the client. So that means the coAP protocol work here in a very simple manner by exchanging the request and the response messages. So these are basically an asynchronous mode of transfer of these messages in this protocol here. So the message type basically includes, like here, this message: confirmed message, not confirmed message, acknowledgement, and if a connection reset is required here. So when client is here making a request, that will be here forwarded. That means the datagram here will have working with the UDP, forwarding the request from the client to the server, and when the server has reply back to the client, then the various response messages will be used here. Now, these are like for caching, a certain message will be used, and for the resource discovery by the client, another request messages will be forwarded to the server. So for that, now we will see the header format here for this protocol. This was just a demonstration that how internet here is clubbed with this constrained environment and how two devices are here, or we can say that the server here and the client device in your constrained network is using this constraint protocol for exchanging the information. So for this, the first field here is VER, then you have the type of transaction, then you have option count, then the next one is your code, and then ID, which is basically your message ID. Then you have some optional fields also here. So they are provided if any other options are required and for payload. So this field is your version, which is the version 1 for this protocol. Now next one which we have here is your team. So this field basically refers to the type of transaction and the type of transmission here between the nodes. So this will be the different messages: you confirmed, not confirmed, acknowledged, and reset. Now after that, the next field which we have here is your OC, which is your option count. So this basically tells here that number of options which are available after this field. Next is your code. So code is basically the request and response messages, because we have a different number of request and response messages to enable the communication. So from like 1 to 10, code 1, code 2 up to code 3, there will be the request messages, and then from this series we have the different response messages which will be forwarded from your server through the coAP protocol to the client. Then we have the message ID. So message ID is basically identifier for matching the response. That means the message which is incorporated here with the protocol that is used to match that whether it is matching the particular response here or not. So this protocol, as I said earlier, is mapped here with HTTP. That means this is basically used to access the internet services. So these are here working on your application format. So this is one of the constraint protocol which we have studied here for IoT. So there are other protocols also which we will cover in our next session. So this is all here for today's session. Thank you so much.